All right, greetings everyone. This is the first part of the video for section 1.5. And in section 1.5, we're going to start talking about what are called transformations of functions. So we spent the first few sections looking at properties of functions, different types of functions, different ways to represent functions. And I know you all have been diligently studying your toolkit functions. So now we're going to look and see what happens if we start making changes to those functions. So that's where that term transformations is referring to. Okay, so as I mentioned, this is section 1.5. And what we're going to do is we're going to look at some variations on the function f of x equals x squared. Now, do you recall from your list of toolkit functions, which toolkit is this? Right, this is the quadratic toolkit function. Okay, and we're going to graph it on a graphing app here in a minute, but before we do that, just quickly remind ourselves what the graph of this looks like. So recall the quadratic function has this kind of U shape, and on the bottom there it should actually go through the origin. So let me fix that. There we go. So it looks something like this. And we call that shape, for some of you that may know the name of that, that is called a parabola. Okay, and you'll see here I've got this list of different transformations of that function. So adding numbers on the outside of the x squared, also on the inside of the x squared, and all those sorts of things. So let's look at how this changes the graph. So what I'm going to do is I'm going to switch over to Desmos here. Okay. And I'm going to start by just graphing that original function, so the f of x equals x squared, so that's the red one there. And Desmos doesn't do a good job of showing this, but we all know that the graph does not stop up here. There should be arrows on the end here, so these are going forever and ever in each direction. And then we're going to look at some transformations. So the first one we're going to look at is what happens if we take and subtract 2 from the equation of this. So I'm going to call this g of x equals, it'll be x squared. So notice it makes a blue graph right over top of the other one. But then I'm going to subtract 2 from it. And notice what happened to the graph of that function to go from the red to the blue. Well, it looks like everything moved down 2 spaces, right? If we look at, say, this point, not that, sorry. Look at, say, this point here compared to this one. They're in the same place on each graph. Notice they move down 2. And also if we look at this one here, at that point, let's see, that's 2, 4. That point got moved down 2 spots here to 2, 2. Okay, so there seems to be kind of a movement downwards in this case. Let's see what happens if we now graph a function where we take x squared and add something to it. So now we're going to do h, oh boy, h of x equals x squared again, but this time we're going to add 2 to the function. And notice what happens here to give the green function. Well, now it looks like everything got moved up 2 units, right? So again, this point here moved up to here. That point that was 4, 2 here is now up here at, or sorry, 2, 4 is now at 2, 6. Okay, so everything got moved up 2 units. So what can we conclude about what that tells us about adding or subtracting a number to the equation of a function? Well, it looks like it causes some sort of a shift up or down, right? And also notice, okay, if it's shifting up or down, it's moving up or down on the vertical axis, right? So notice that those points we looked at, say the 2, 4, the 2, 6, and the 2, 2. In all of those points, the input value, the 2, stayed the same. So what changed? The output values, right? So shifting up or down changes your output values. All right. Okay, so I'm going to clear these out now, these extra ones. So we're back to just our f of x equals x squared. And now we're going to do some transformations where we add or subtract a number, but this time we're going to do it on the inside of the squared term. Okay, so now I'm going to do a function I'm going to call k of x equals, and I'm going to subtract 2 on the inside of my squared. So I have x minus 2, and that's going to be inside the squared function. And notice what happened there to go from the red to the, is that like purple? Okay, well, in this case, if we again look at this point right here at the origin, looks like this time it moved to the right, right? So it didn't move up or down at all, but it moved to the right. Similarly, if we look at this point here, this 2, 4, notice that it moved over 2 units to here. Interesting. It's also interesting that it moved to the right in the more positive direction, even though there's a minus 2 here. That's interesting, right? Okay. Well, let's do another function now where instead of subtracting 2, let's add 2 this time. And notice what this did then is move the function to the left, right? So now we see that going from this point here to this one, we moved left 2 units. And going from this one here, which was negative 2, 4, it moved over to the left to negative 4, 4. Okay, so it looks like that moved things to the left, and notice it did that even though there's a plus here, right? So it looks like adding or subtracting numbers on the inside of our function here now moves things left or right, okay? And notice that when it moves things, it moves them differently than we may think, right? So again, a minus 2, that makes us maybe think of moving left because there's a minus, but notice that moved to the right. And then the plus 2, which maybe usually makes us think of adding 2 or moving to the right, actually that made us move to the left, okay? So it looks like adding something on the inside of the function moves things left or right, and it also does the opposite of what we thought, right? If it's minus, it goes to the right. If it's plus, it goes to the left, okay? All right, so let's summarize our findings here, and we're going to go back to the PowerPoint. And this slide here summarizes the things we saw. So if we have a function f of x, so that would be like our x squared on the where we were graphing, and we define a new function by taking that function and adding or subtracting something to it. Okay, well this is what happens. If that value is positive, so if you're adding, the graph shifts up. If that value is negative, meaning subtracting, then that value shifts down, okay? And also notice, as I pointed out, okay, it says here, that shift impacts the output values. And I'll highlight that this number that you're adding or subtracting is being done on the outside of the function, and so it impacts the output values. Okay, so it changes your values on the vertical axis. On the other hand, if we are now adding something or subtracting something on the inside of the function, so notice this is inside the function, okay, well, that's what we saw with the second set of graphs. So if that number is positive, it means you're adding something. Remember, again, this does the opposite of what you think, so it shifts left. If that's negative, meaning you're subtracting something, then it shifts to the right, okay? And one way to think about that is one of our instructors that used to teach at Pierce like to talk about this inside of the function. We sometimes call this the house of lies. Okay, because on the inside of the function, it does the opposite of what we would think. So again, adding actually means moving to the left, subtracting means moving to the right. So it's a house of lies there. The other thing is, it doesn't say it here, but because this is on the inside, it impacts inputs. Okay, so we saw with the outside up above, when you had stuff being added or subtracted on the outside, it impacted the outputs. When you do it on the inside, it impacts your inputs. Okay? All right, and this is maybe something you want to go back in the video and review, because I know there's a lot going on here. All right, let's look at now what happens if we take a function. And in this case, we're going to use f of x equals square root of x, which of our toolkits is that? Right, that's our square root function, because it's square root. And look at what happens if we put negative signs in different places. Okay, so I'm going to go back to Desmos. All right, and I'm going to clear out these functions. I'm going to start now with the function f of x equals square root of x. And for those of you who are using Desmos, maybe yourselves, to do a square root on here, you can do sqrt and it'll give you a square root. So there's our square root of x, the red graph. And let's look at what happens if we do a negative sign on the outside of that graph, or that function, excuse me. So I'm going to do negative now, square root of x. And what do you notice? To go from the red to the blue there, well, it looks like the function kind of flipped from up, or from concave down to concave up, but it flipped across what? It looks like it flipped across the horizontal axis, which if you're using x's and y's, that would be your x-axis, but since we're talking about inputs and outputs, it flipped across our horizontal axis there. And I'm actually going to leave this graph on here. So this is going to be j of x equals negative square root of x. Okay, negative square root of x. All right, well, let's look at what happens now when we put the negative sign on the inside. So now I'm going to have a function I'm going to call p of x equals the square root of negative x. And what happened here to go from the red to the green? Well, notice in this case, it kind of did a reflection again, right, or a flip, but it flipped across what this time? That's right, it flipped across the vertical axis with that negative sign on the inside. So this function right here, called p of x equals the square root of negative x. And then finally, let's look at what happens if we do negatives on both the inside and the outside. So I'm going to call this function L of x, and that's going to be the negative of the square root of negative x. And notice that now is this graph that ends up down here in the lower corner. And can you kind of see, based on what we did in the previous two functions, how it got there? Well, it looks like perhaps we did a reflection or a flip across the vertical axis, and then flipped again across the horizontal axis to get there. And or we flipped across the vertical or the horizontal axis and then the vertical axis. And hopefully you notice that would give us the same function there. So what can we conclude? Well, it looks like those negative signs are causing flips across the different axes. And I use this word a couple of times already to describe what those are. Those are actually called reflections. Okay. So let me go back to here. All right, so that gives us this set of stuff here. So when you have a function f, let's say, and you put a negative sign in the front, that calls it as a vertical reflection. But notice here it says it's reflecting across the x-axis, which we're not going to call it the x-axis, we're going to call it the horizontal axis. Okay, so a vertical reflection, a negative on the outside, flips or reflects over the horizontal axis, which I know may sound strange because it's vertical reflection, but it's across the horizontal axis. And then a negative on the inside causes what we call a horizontal reflection. That's a reflection across what it calls here the y-axis, or that would be the vertical axis if we're not using x's and y's. Okay, so that's what those negative signs on the inside or outside do. All right, last thing for this part of the video. I'm actually going to skip this part. Let's talk about what are called even and odd functions. And they've got a really technical definition here about how even function means f of x equals f of negative x, and f of x equals negative f of negative x. But what I want us to focus on are these definitions here. So even and odd functions, okay, are not about powers. So sometimes people think that if I'm talking about even or odd functions, I mean something like f of x equals x squared or f of x equals x cubed. Okay, and because the 2 here is even, we think even, 3 here is odd, that means odd. That's not what we're talking about. What we're talking about is symmetry. Okay, so let me show you what I mean for an even function. So an even function, as it says here, is a function that is symmetric about the vertical axis. So an example of that, and I know this is the graph of f of x equals x squared, but this is even not because the power is 2, but because of how it's symmetric. So notice that that graph there, if I took, say, the right-hand part here, and I folded it across the vertical axis to the left, it would fold right on top of that other piece. So that's what makes it an even function, is it has that symmetricness, or you can fold it across the vertical axis and it'll line up with itself. On the flip side, an odd function, it says here, is symmetric about the origin. And let me give you an example of that. And so I'm going to do a graph like this. And yes, I know now this is the graph of f of x equals x cubed, which has that odd power. But again, I want to reiterate, it has nothing to do with the power. It has to do with symmetricness. So here it says it's symmetric about the origin, which is kind of technical and would mean, like, if I look at a point up here, reflect across the origin, which is this, over to here, I can find a corresponding point. That's kind of a hard way to think about it. The way I prefer to think about odd functions are we can do both a horizontal and a vertical reflection, and the function will line up with itself. So notice if I take, say, this piece of the graph here, I reflect it across the vertical axis, so over to here, and then also reflect that piece across the horizontal axis, notice it lines up perfectly with itself. Okay. Similarly, I could also take the piece here, reflect it across the horizontal axis, so down to here, and then reflect it again across the vertical axis down to here, and notice again that it lines up with itself. So that would be an odd function. Right? In case you're wondering, yes, there are functions that are neither even nor odd. So if you look at, say, this function here, okay, so which function is this? Well, that's the square root function, right, when we were just looking at a few minutes ago. And notice with this one, if I reflect it across the vertical axis, well, it doesn't line up with itself, so it's not even. And if I take that piece then and also reflect it across the horizontal axis, well, it still doesn't line up with itself. And with itself, I mean that original yellow function. So that one is neither. So this one is neither even nor odd. Okay. All right, that's all for now. Thank you for watching.